This video is going to cover the solutions to the 5-3 and 5-4 extra review. So we'll start with the top ones, 34 and 36. These are based on your 30, 60, 90 and your 45, 45, 90 triangle. So if I look at the first one, on the left, I've got a 30, 60, 90. This at the top would be 30. On the right, you've got 45, 45, 90. So the relationship between the sides in the one on the left, the 30, 60, 90, this would be your x, this would be x root 3, and this would be 2x. So because that's the value I have, I can say x is 24, and that gives me the bottom side here. So A is 24. B here would be 24 times the square root of 3. And then that feeds into the triangle on the right. So if in a 45, 45, 90 triangle, let's just say that this is y and this is y, so we have a different variable. This would be y root 2. So if y equals 24 root 3, so would D down here, so D would equal the same thing. And then C would equal 24 square root 3 times the square root of 2, which becomes 24 square root 6. So that's C. For 36, again, you've got a 45, 45, 90 triangle, this time on the left, and then the 30, 60, 90 triangle on the right. This time, 30, now let's make this again x. This would be 2x, and this would be x root 3, and that's the value that you have. So if 7 equals x root 3, then to work backwards, we'd have to divide both sides by the square root of 3 and rationalize it. So I'd get 7 square root 3 over 3. That's going to be the x value, which is m. And then because this is 2 times that, 2 times 7 square root 3 over 3, that would be 14 square root 3 over 3. That's going to be A. And that feeds into the other triangle. So in the 45, 45, 90 triangle, these two are the same. So if that A is 14 square root 3 over 3, so is this side, which means N is 14 square root 3 over 3. And then this would be 2 times 14 square root 3 over 3. And that gives me Q is 28 square root 3 over 3. For 38, this says to actually find a formula for the area of the triangle. So I know a triangle has the area 1/2 base times height. The base would be this S. The height would cut this into 2, 30, 60, 90 triangles. So if opposite the 30, well, if opposite the 90 is the S, right? Opposite the 30 would be 1/2 that, which makes sense because when I cut that triangle in half with the altitude, it's going to break that S into 2 parts. And then the height would be the 1/2 S times the square root of 3. So I'd get 1/2 the base, which is S, the full base, and then the height, which would be 1/2 S square root 3. So 1/2 times 1/2 would just be 1/4. And then S squared times the square root of 3, and that would give you the formula for the area. Okay, then it says find the exact values of the 6 trig functions for each angle, rationalize the denominator when applicable. So if I'm trying to find the 6 trig values for 300, okay, think 300 is in your 4th quadrant, so that helps me with all students take calculus. The reference angle here is what I'm going to find. So the reference angle would be 360 minus 300, which is 60 degrees. So in a 30, 60, 90 triangle, opposite the 30 is 1, opposite the 60 is root 3, and opposite the 90 is 2. And I'm using the 60 degrees, so that's at the top. So the sine is going to be opposite, which is root 3, over hypotenuse, which is 2. The cosine is going to be adjacent, which is 1, over hypotenuse, which is 2. The tangent is going to be opposite over adjacent, so root 3 over 1, which is root 3. The cosecant would be 2 over root 3, and that gets rationalized to 2 root 3 over 3. Secant, 2, cotangent, square root of 3 over, 1 over square root of 3, which gets rationalized to root 3 over 3. Now we have to look at the positive negative signs. So because it's in the fourth quadrant, I know cosine and its reciprocal function, which is secant, are positive. Everything else is negative. So sine's going to be negative, cosecant's going to be negative, tangent's going to be negative, and cotangent is going to be negative. So sine, cosine, tangent, cosecant, secant, and cotangent. All right, 60 is 405. Now 405 is bigger than 360, so we can easily find a coterminal angle by subtracting 360 from it, and I get 45. So now I know 45 degrees is in my first quadrant. Everything's going to be positive, and I'm using a 45, 45, 90 triangle. 1, 1, root 2. So the sine is 1 over root 2, which becomes root 2 over 2. The cosine is the same, 1 over root 2, which would be root 2 over 2. The tangent is 1 over 1, which is 1. The cosecant is the reciprocal before you flipped it, so it's just root 2. Before you rationalized it. The secant would just be root 2, and the cotangent would be 1. And again, because that 45 is in the first quadrant, everything's positive. Now we go negative 510. If the negatives throw you off, then you can find a coterminal. So I can take negative 510 and add 360 to it. And I'd get negative 150. Find another coterminal by adding 360. And I'd get 210. So 210 would end up in the third quadrant. I would do 210 minus 180, and 30 degrees is my reference angle. So I'm using my 30, 60, 90 triangle, but this time I'm using the 60. 1, root 3, and 2. So I'm using this corner. So sine, opposite over hypotenuse, 1/2. Cosine, root 3 over 2. Tangent, 1 over root 3, which gets rationalized to root 3 over 3. Cosecant is 2. Secant is 2 over root 3, which gets rationalized to 2 root 3 over 3. And cotangent, flip it before we rationalize it, so it's root 3. Now that angle is in, like we said, the third quadrant. All students take calculus. Tangent and its reciprocal function, which are cotangent, are positive. Everything else is negative. So sine, cosine, cosecant, secant, tangent, and cotangent. Okay, 64 and 66 are similar, except they just want one trig function. So I've got sine of 1305. Obviously, I need to subtract 360 until I get it in between 360 and 0. So 1305 minus 360 is 945. Do it again. 585. Do it again. 225. So 225, third quadrant. Reference angle there would be 225 minus 180, which is 45. And I know I'm dealing with my 45, 45, 90 triangle. The sine there is 1 over square root 2, which gets rationalized to root 2 over 2. Sine in the third quadrant is negative, so it'd be negative square root 2 over 2. Tangent of negative 1020, I'm going to add 360. I can even just skip and add 720 because obviously I know I'm going to have to do it more than once. This is negative 660 plus 360, negative 300. Plus 360, and I get a positive 60. That puts me in the first quadrant. So I know everything is positive. 60 degrees, I'm using this triangle up here, but I'm looking at the 60 this time. Tangent is opposite over adjacent, which is root 3 over 1, just root 3. Okay, then it says to use the calculator to find a decimal approximation for each value, and then give as many digits as your calculator displays. Simplify the expression before using the calculator. So when you think about the separation of your test, these would be on Friday. In which you'll have a calculator for. So you can either use the DMS menu or the angle menu on your calculator to type that in, or this one's an easy one. 30 divided by 60 is 0.5. So 30 divided by 60 gives me, would this convert to 29.5? So then the tangent of 29.5 is 0.56, and it says give as many digits as on your calculator display. So 577277782. You'll round it for your test. 78 is cosecant. So I have to do 1 over sine, and again 45 divided by 60 gives me that 0.75. So this one's also easy to convert. 1 divided by the sine of 145, 0.75. And I get 1.776814578. And the last one, this 30 over 60 again would be 421.5 cosine 421.5. And I get 0.4771587603. Okay, page 2 starts with my inverse functions. So now this says find the values of theta from 0 to 360 that satisfies the statement. Leave the answers in decimal degree. So the first thing I'm going to do is for 90, sine of -1 of this whole thing. So second sine 0.848029194. And I get 57.997 degrees. Now that's in the first quadrant, so you also have to use, all students take calculus to determine where else sine is positive. That's in the second quadrant. So I'm going to include that 57.997, but then I'm also going to do, because the second quadrant, 180 minus that value. To get the second angle, which would be 122.003. Now these are easy to check. Remember, if you just do sine of 57.997, you should get pretty close to your original question. It might be a little bit rounded, but it should be close. Same thing for sine of 122.003. Should get the same value. Now secant, I have to do the reciprocal function, which is cosine, -1, but then I do 1 over 1.1606249. So second, cosine 1 divided by 1.1606249. And I get theta is 30.503 degrees. Cosine is positive in the first quadrant, which is where we're at, and in the fourth quadrant. So I would do 360 minus that angle. To get the second angle, which is 329.497 degrees. The next section says find all the values of theta if theta is in the interval of 0 to 360 and has the given function value. So now we're not using our calculators. Now we're using our triangles. So we want to set up the two triangles, which would be 30, 60, 90, and 45, 45, 90. 1 root 2, 1 root 3, and 2. So for sine to be 1 over 2, we're talking about opposite and hypotenuse to be 1/2. So what angle has 1 opposite and 2 the hypotenuse? I know I'm talking about this top triangle, and opposite the 1 is 30 degrees. So I know theta is 30 degrees. And it's from 0 to 360, so I want to find the other angle in which, again, sine is positive. That happens in the second quadrant, so I would do 180 minus 30 and get that the other angle this happens is 150 degrees. Now look at 96. It says root 3, so I'm going to ignore the sine first and just deal with the tangent of root 3. So the triangle that has root 3 is again the 30, 60, 90. Tangent would be opposite over adjacent. So in which of these angles is the root 3 opposite? And that's 60 degrees. Adjacent is 1, so that matches up. So I would say that tangent is originally 60 degrees. But because it's negative, and again, all students take calculus, tangent's negative in the second quadrant and the fourth quadrant. So I'm going to use that 60 degrees to subtract it from 180 and get 120. That's the first angle. And then I'm going to use the 360 degrees and subtract 60 from it and get 300, and that's the second angle. So 120 and 300 degrees are the ones that have negative root 3. And now 98 is cotangent. So cotangent being negative root 3 over 3. This means this was rationalized. So this was 1 over square root 3. And cotangent's adjacent over opposite. So if I go back to the circle, again, the triangles, again, I'm going to use the root 3 one, which is that top one. The adjacent side being 1 and the opposite side being 3 is still 60 degrees. So I'm looking at 60 degrees and where cotangent is negative, which means tangent's also negative. It's the same two quadrants as that last one, which means it'd be 180 minus 60 again, which was 120, and 360 minus 60 again, which is 300. Okay, these last four are dealing with solving your right triangles. So for number 1, I'm going to draw it down here. I'm going to draw out my triangle. I've got A, B, C is the right angle. It says so up here. Angle B is 63 degrees and side C is 15. This means I'm missing angle A, side A, and side C. Nope, sorry, side B. I can find angle A by doing 90 minus 63, which is 27 degrees. And then I want to pair what I'm given with what I'm looking for. So if I'm looking for A, let's say, angle B is adjacent to A and 15 is the hypotenuse. So adjacent and hypotenuse is cosine. Cosine of 63 would equal A over 15. And then I'd multiply by 15 on both sides. 15 cosine 63 gives me A is 6.8098. We're going to round to the nearest tenth here, so 6.8. Now if I want to find B, I still want to use the information that they gave me. So in respect to the 63, B is opposite, 15 is still hypotenuse. So I would do sine. Sine of 63 equals B over 15. And numbers in the bottom, so I'm going to multiply 15 sine of 63. And B is 13.36. This is going to bump that to 13.4. Number 2 here, draw my triangle. A, B, C. Doesn't matter where A and B go as long as the C is the right angle. B is 11. Angle B is 46. I'm missing angle A, side A, and side C. Angle A is 90 minus 46, 44 degrees. I want to use what they gave me, the 46 angle and the 11. And I want to find A. So in respect to 46, A is adjacent, 11 is opposite. So this is tangent. Tangent of 46 equals opposite, which is 11 over A. The number's in the numerator this time, so I divide it. A equals 11 divided by the tangent of 46. And I get A is 10.62, which is going to be 10.6. Then C, I can find two ways. One is Pythagorean Theorem. So I can do 11 squared plus 10.6 squared equals C squared. 121 plus 10.6 squared 112.36 equals c squared. So c squared equals 233.36. Square root that number. And I get c equals 15.3. We can also use SOHCAHTOA. So b is still opposite the 11, and c would be the hypotenuse. I could have said sine of 46 equals 11 over c, and then take the 11, divide it by the sine of 46, and I get c is 15.29, which again rounds to 15.3. So either way, you get that same answer. Okay, moving on to number 3. So 3 gives me, sorry, I just realized I used the old one of these and I had changed it. So for number 3, again, you want to label A, B, C. C is the right angle. This time they gave me side B and they gave me side A. I don't have side C and I don't have either angle. So I can find A by doing the Pythagorean Theorem. Or sorry, I can find C by doing the Pythagorean Theorem. .24. So we're going to say C is 12.2. And then I want to do angle A and angle B, but I want to use the sides that they originally gave me because those are accurate. So for A, 9 is opposite, 13's adjacent. So the tangent of A is equal to 9 over 13. And I'm looking for the angle, so I do the inverse tangent. Angle A, 34.69, so we're going to round that to 34.7. And then for B, again, I could do 90 minus 34.7, which is 55.3, or I can use the trig function for B. 13 is opposite and 9 is adjacent, so it would be the tangent of angle B would equal 13 over 9. Second tangent, 13 divided by 9, and I'd get that same answer, 55.3. Let me write this up here. So either way you find that last angle, you get the same answer. Okay, last one, and this is 4. So again, this time I gave you 2 side lengths. I gave you A and C. C is 9 and A is 6.5. So when I want to find that third side, I can do the Pythagorean Theorem. It would be 6.22, so we're going to keep it as 6.2. So that's side B. I need angle A and I need angle B. So angle A, I want to use the ones they originally gave me. 6.5 is opposite and 9 is hypotenuse. So I'm using the sine this time. Sine of A would equal 6.5 over 9. Sine -1 of 6.5 over 9. And I get angle A equals 46.23. So 90 minus 46.2 gives me B is 43.8. But I can also say B, this would be adjacent, this would be hypotenuse. So the cosine of B would be 6.5 over 9, cosine -1 of 6.5 over 9. And I get 43.76, which rounds to 43.8 again. All right, that's the solutions for this extra practice. If you're still feeling confused, please reach out. You can send me a message or an email, and I will try to get back to you as soon as I can. Have a great day.